All right, for this next section, we're going to focus on factoring. This is all from 3.4. And the thing that's special about this factoring section is that we can't use the quadratic formula here. The idea of factoring is to break something up into its multiplied parts. So you can't use quadratic formula because quadratic formula is a solving method. So we have to use our factoring methods that we've looked at all chapter long. Now you've got your decision tree that you're going to be able to bring to the test. And so you need to use that decision tree to kind of figure out what you want to do. All right, so since we're just factoring here and we aren't actually solving, we don't have like an equals 0 on the side here. The first question on the decision tree isn't going to be important, right? That says, is there a 0 on one side of the equation? We don't have equations, we just have expressions. So we're going to move down to the second question of the decision tree, which is there a common factor among all the terms? Okay, so let's take a look at 16 to get us started, right? Is there a common factor between the 10x squared, the 31x, and the negative 14? So the answer is no. There's no number that could be divided out of all three of them, and they don't even all have an x. So we have to skip down to the part of the decision tree that says how many terms are there. So this one has 3 terms. So we're going to follow the decision tree over. The next question is the a value 1? The a value here is actually 10. So because the a value is 10, our only option is going to be to do the AC method. The AC method is the most involved of the factoring methods because you have to do a couple different factoring methods just to do the AC method. All right, so we're going to take our a value, 10, and our c value, negative 14. We're going to multiply those two together. That gives us the value negative 140. That value is what we're going to do x factors with. So instead of doing x factors with a negative 14 being our target multiplication value, our target multiplication value is going to be negative 140. And our target addition value is still going to be the middle term here, which is a positive 31. So our job is to find two numbers that multiply to make negative 140, but those same two numbers add to make 31. And this is a guessing game, right? Like you just have to play around with it until you find the right numbers, right? What I'll do often is I'll just start listing out factors of 140. So I'll say 1 and 140, 2 and 70. If you don't know if a number divides, like if you think like what's 140 divided by 3, you just got to check on your calculator. 140 does not divide evenly with 3. So you can do 4 and 35. And you can keep going and keep listing values out until you find a combination that could actually add or subtract to make a 31. I'm going to stop right here at 4 and 35 because I know those two can combine to make a 31. Specifically, we need a positive 31. So that means the 35 has to be the positive number, and that means the 4 has to be the negative number. All right, now that we've solved that puzzle, we're going to come back up here to the original, and we're going to rewrite it. But this time, we're going to break up that 31x into the two numbers that we just found here. So 31x is going to break up into a negative 4x and a positive 35x. And then we have the minus 14 on the end. Now that we've broken up 31x, we can finish this off by just doing the grouping method, where you look at the first two, find out what they have in common, look at the second two, and find out what they have in common. So the first two, 10x squared minus 4x, they have a 2 in common, and they both have an x in common. So we're going to factor out a 2x. 10 divided by 2 makes a 5, and x squared, taking out 1x, leaves 1x behind. And then the negative 4x, negative 4 divided by 2 leaves behind a negative 2. And since there was 1x and we took it out, that's all that's left out. All right, great. We want to see the same thing in the parentheses when we do that with the second group. So what do 35x minus 14 have in common? Well, they both have a 7. So we're going to factor out a positive 7. Since the first number here isn't negative, there's no reason to make it negative. And 35 divided by 7 leaves a 5. That x stays there. And then a negative 14 divided by 7 makes a negative 2. And thank goodness we got the same thing in both places. So that means it worked out. So we're going to group together then the 2x and the 7 into one parenthesis. And then both of those two numbers are multiplying the other parenthesis, which is 5x minus 2. No need to put a squared on the 5x minus 2 because even though up here it shows up twice, because we group the 2x and the 7 together, we just are saying that 2x plus 7, both of those pieces are multiplying by the 5x minus 2. All right, so it's factored and it's done. That's the AC method. All right, let's do the other three. We're probably not going to see another AC method since we saw one of those already. So these ones will probably be a little quicker, a little easier. All right, so let's check out. The second step on the decision tree is there anything in common here? So in this one, there is actually something in common. 98 and 2 can both be divided by 2. So we're going to pull out that common factor. So that's the first method that we're using here. So that common factor is a 2. But the decision tree also mentions what if the a value is negative, or what if the first value is negative? If it is, you should factor that negative out as well. It's always going to be better for you. So if we take out a negative 2, that means that this first term would only be an x squared left. And 98 divided by negative 2 would actually create a negative 49. Now the benefit of pulling that negative 2 out is that now we can see this and it's a little bit more simplified. Now maybe this fits a factoring pattern that we noticed. So if you go to your decision tree, this thing only has 2 terms. So go to the 2 term section of your decision tree. And one of the options there says, are both terms perfect squares? Well, 49 is a perfect square because it's 7 squared. And x squared is a perfect square because it's x squared. And is there a subtraction between? And there is, after we factored that negative 2 out. So we can use difference of squares to finish this up. So after factoring out the common factor, that was method number 1, then we use difference of squares. Difference of squares, you might remember, requires you to identify what's being squared in the first slot and what's being squared in the second slot. So the first slot is x squared. The second one is 7 squared. So x and 7, those are going to be the 2 numbers that you put into parentheses. So it's going to be x plus 7 and x minus 7. And don't forget that negative 2 that we factored out at the very beginning. All right, let's go on to number 18. First check, is there any common terms, any common factors that we can pull out? 10 and 24 have common factors, but the x squared doesn't. X squared and the 10x have a common x, but the negative 24 doesn't. So common factors is not going to work here. So that means we can jump straight to the number of terms. There are 3 terms here. And so then the next question is the a value 1? The a value is 1. And that tells us to try out reverse FOIL. It won't always work, but because this is in the factoring section, there is a high probability that reverse FOIL will actually work. If this was in the solving section, maybe we'd have to use quadratic formula, but let's try it out. So this is basically the x factors game. Because this is not the AC method, we can just take the negative 24 directly. That's going to be our multiplication number. We're going to try to multiply to make negative 24. And we take the middle number, negative 10. That's the number we try to add to be. And then we just try possibilities. So what two numbers multiply to make negative 24? So that's a 1 and a 24, a 2 and a 12, a 3 and an 8, a 4 and a 6. Now, which one of these will actually add to make a negative 10, but multiply to make a negative 24 specifically? You can see that there's actually two options here. A 4 and a 6 could add to make a 10, but a 2 and a 12 could also. So we got to make sure we get the right one. We actually kind of have to be careful here. So if we choose the 2 and the 12, that would mean that the 2 would have to be positive and the 12 would have to be negative. So you should just double check that this actually works. So 2 plus negative 12 does make a negative 10. 2 times negative 12 does make a negative 24. So that number is correct. I've seen a lot of students make mistakes with this, where they take the 4 and the 6 and they try to make it fit the negative 10 and the negative 24. The negatives and positives actually don't work out. So the 2 and the 12 is the only one that makes sense. Now, because you're doing reverse FOIL, as soon as you pick these two numbers, you're basically done, because those are the two numbers that you write into your parentheses as you factor it. You don't have to do anything else. You just, if it's positive 2 and negative 12, you just do x plus 2, x minus 12, and that's it. All right, one more in this section of factoring. All right, so we're going to start off right at the top of the decision tree. Once again, that second step, because we don't have an equation here, is there anything in common? There is definitely some common stuff between negative 16 and 20. There's also common variables as well. So our first factoring method is going to be that common factor. So what's the largest number that 16 and 20 have in common? That's going to be a 4. Because the leading term here is a negative, we're going to go ahead and take a negative out as well. And because both of them have an x, we're going to go ahead and take an x out as well. So what's left over after we divide out a negative 4x? So negative 16 divided by negative 4 would leave us with a positive 4. If we take 1x out of x squared, that leaves us with an x. Then we move to the second term. 20 divided by negative 4 would leave us with a negative 5. And then there's just one x there, and we took it out. So there's no more x's left. And that's actually it. By factoring out the common factor, we actually broke this x squared down into two separated x's. That's all you have to do. You don't have to do any more factoring, because just taking out the common term did the factoring for you. Now, I'll point out before I end this video that in number 17, taking out the common factor did not end it for us, because when we took out the common factor in number 17, it did not break this x squared down into a lower power of x. That's because the x wasn't in common. The 98 didn't have an x with it as well. But in number 19, because they both had an x on them, when we pulled that x out, that did all the factoring we needed to do, because it broke down both of the x's into x to the power of 1. And that's kind of how you know that you're done factoring, when x is to the power of 1. Now, I'm going to go ahead and throw in completing the square, so number 20, into this video, just because it's a section by itself, and it shouldn't take too much time to go through. All right, so in this case, using completing the square, this will always be when you're solving. So this will always be when there's an equals sign. And when you complete the square, it's okay to start with with the equation equaling 0, but we are going to have to. One of the first thing of completing the square is to take this number here and shift it over to the other side. So if you're using your decision tree to do this, and you're completing the square, like you could have a 0 on one side, but you actually are just going to move that c value over right away anyway. So it's actually okay if there's not a 0 on one side. But anyway, it's no harm, no foul if you do move something over just to move it back. So we're going to subtract 50 over to this side. And what that does is it gives us the x squared minus the 14x with an open space for its c value. On the other side, we now have a negative 50. And what we want to do to complete the square is we want to figure out what number should go in this space so that it makes this whole trinomial become a perfect square trinomial. Now, whatever we end up adding in this space, we're going to need to add that same value over here. So I'm going to put a space over here just to remind me that whatever we put here, we need to match it over here. All right. So the way to figure this out, we learned in class, is to look at that middle term, negative 14. When we factor this out, after we've completed the square, when we factor this out, it's going to be x minus or plus something squared. And the number that goes in this parenthesis can be figured out by just figuring out what's half of this b value. So we need to cut b in half. So negative 14 divided by 2 means that the number that's going to come here is going to be a negative 7. Okay, well that's great, but we still need to know what number needs to go here to make that happen. So in order to get this number in the blank, we have to take that negative 7 and square. We have to do negative 7 times negative 7. So negative 7 times negative 7 means we would need to add a 49 here. To balance out the equation, we would need to add a 49 over here as well. And that's going to be what allows us to factor this out to x minus 7 squared. Now we have to combine the negative 50 with the 49. That would leave us with a negative 1. The whole point of completing the square is to get it into this form that we just got. So we have x minus 7 squared equals negative 1. At this point, because the entire expression on the left side is getting squared, we can just square root that to get rid of the squared there. To match it, we have to square root on the other side. And we learned something in class about introducing a square root to an equation. And that is that anytime you're the one that puts the square root in, you have to allow for the positive or negative version of it. So now that we've square rooted, on this side, the square root and the square cancel, leaving us with an x minus 7. On this side, we have a plus or minus square root of negative 1, which hopefully you know the square root of negative 1 is actually I. So we can translate that into I, and then to get x all by itself, we're just going to simply add that 7 over to the other side. So that would be a positive 7 on that side with a plus or minus I. So your actual answers then, there's still two answers here. You can actually write your answer just like this if you want to. But for those of you that like to show both answers, you could say that one answer is 7 plus I, and one answer is 7 minus I. Those are your two answers. They're both imaginary answers, but that's what comes from completing the square.